If you simplify further, you will get an is equal to 18 epsilon by n square pi square into sin n pi by 3 minus sin n pi is 0. This will become 0 minus cos n pi into sin n pi by 3. This is nothing but 18 epsilon by n square pi square sin n pi by 3 plus 18 epsilon n square pi square sin n pi by 3 into cos n pi. Now I will take 18 epsilon by n square pi square sin n pi by 3 as common. You will get 1 plus cos n pi. So we know in Fourier series cos n pi value is n square by pi square. This is sin n pi by 3 as it is. You will get 1 plus minus 1 power n. For odd values of n, you will get minus 1. For even values of n, you will get plus 1. Okay. So this is for an. If I write it for a2n, you will get 18 epsilon by n square pi square 2m, make it 2m, so that it will be 2m 4m square. In the place of n, I am replacing 2m. So n square means 2m whole square. 2 times of into sin 2m pi by 3 into 1 plus minus 1 power 2m. Okay. Now, if n is odd and equal to 2m minus 1. Sorry. This is if n is even and the value of that n is 2m. The even number I am choosing it as 2m. So your an value will become this. Now the final expression will be, or solution will be, 9 epsilon by pi square into m square sin 2m pi by 3 into sin m pi x by 3a into cos of m pi ct by 3a. Now you have found out the value of an when n is even, that is when n takes the value 2m, and you are substituting that value in your general equation. In the place of an, you are substituting that value, so that you will get this. Here also you should substitute in the place of n. You have to substitute 2m. Okay. So this 1 plus minus 1 power 2m becomes 2, because 2m is even. So minus 1 power 2 means it is plus 1. Plus 1 plus 1 will give you 2. That 2 I have written here. In the same way, I have solved one more problem for different initial condition. Okay, you can go through it. And in this problem, you have different boundary condition also. So start doing from the beginning, that is at least from after getting general solution. If you substitute the boundary condition, you will get different solution. For first two, you will get a trivial solution itself. But when k is less than 0, you will get different solution. Try that. In this problem, till general solution, you will get the same result. Okay. And when k is equal to 0, you will get a trivial solution. That is u of x comma t is equal to 0. And when k is greater than 0 also, you will get a trivial solution. k is less than 0, you will get this solution, correct? So here if you consider u of 0 comma t is equal to 0, of course you will get c1 is equal to 0. But the another condition is you have to differentiate this u of x comma t with respect to x, then you have to apply the condition. So what you will get if you differentiate with respect to x, c1, okay, I will write it minus lambda c1 sin lambda x plus lambda c2 into cos lambda x into this whole term is constant, so I will rewrite it as it is, sin lambda ct. Now substitute ux of 1 comma t is equal to 0. So what you will do, you will take x of 1 into t of t is equal to 0. This implies x of 1 is equal to 0. So minus lambda c1 sin lambda 1 plus lambda c2 cos lambda 1 is equal to 0. Since c1 is 0, this whole term will be 0. Lambda c2 cos lambda 1 is equal to 0. Now you have to choose the value when cos of what term you will get 0. Okay. So for that I will write it as cos lambda 1 is equal to cos of 2n minus 1 by 2 into pi. For these values you will get 0. If n is equal to 1, it is 2 minus 1 is 1 by 2, that is pi by 2. Cos 90 is 0. Again when n is equal to 2, 2 to the 4, 4 minus 1 is 3 by 2. So cos 3 pi by 2 you will get 0. So for different values of n you will get 0. Now your lambda value become 2n minus 1 by 2 into pi. Now this equation will change. Okay. So what you will get there? You will get if n is equal to 0, 1, 2, 3 so on, you can choose lambda as 2n plus 1 by 2 into pi. If you consider n from 1, then you have to choose 2n minus 1 by 2 into pi. Okay. So I have chosen in this way. So my equation become u of x comma t is equal to summation n is equal to 1 to infinity sin 2n plus 1 by 2 into pi x into an cos 2n plus 1 by 2 pi into t plus bn into sin 2n plus 1 by 2 into pi into t. Now my task is to find out an and bn. So for that we will use the initial conditions. This is your initial condition. So from this you can say that since ut of x comma 0 is 0, there will be no bn terms. You have to find out only an terms. So again your integral part will split into 3 parts. That is, your domain is from 0 to 1. You have 0 to 1 by 2, one function is there. From 1 by 2 to 1 by 4 you have another function, and from 1 by 4 to 1 you have one more function. Since the last term is 0, you will consider these two only. So an is equal to 2 by L, here L value is 1. So I will write 2 itself. 0 to 1 by 4, the function is x into sine 2n plus 1 by 2 into pi x dx plus from 1 by 4 to 1 by 2 the function is 1 by 2 minus x into sine 2n plus 1 by 2 pi x into dx. So now integrate these two terms, apply the limits, you will get a required solution. This is after integration, you will get these terms. So if you apply the limits, 1 over 4 is the first one. So if you simplify this and the second limit, that is lower limit, is 0. So this whole term will get 0. And here upper term is 1 by 2. So 1 by 2 minus 1 by 2, 0. This whole term you will get 0. If you simplify after taking limits, you will get this. So substitute this value here. Since another condition is equal to 0, so you will get Bn term as 0. So finally you will get sine 2n plus 1 by 2 into pi x into 8 sine 2n plus 1 pi by 4 by 2 n plus 1 whole square pi square into cos 2n plus 1 by 2 into pi into t. So that's all the problem is.